Good day, learners. Welcome back to Pedagogical Science Institute School Student Support Program. This is Climatology session number 9, which is the second lesson on the topic tropical cyclones. I am Mr. P. Mbuyisa, your instructor. I'm happy to have you in my online classroom geography series. Without wasting any time, let's just look at what are you supposed to gain from this particular lesson. In the previous lesson, we looked at the first part. In the second lesson, which is this one, we are looking at the second part of our outline, right? Now, we are going to put keen emphasis, keen focus on the associated weather patterns with a tropical cyclone. So we are going to look at the conditions in the eye, the conditions in the eye wall, the conditions in the active quadrant, or what is also known as the dangerous semicircle. In that, I will be showing you how to track the pathway of the tropical cyclone both in the northern hemisphere and southern hemisphere, because most of your examination questions always expect you to be able to do that. Track the pathway and interpret the changes over time at different parts as the system is moving. We are then going to look at the second part of fragment of the lesson, which will be on the impact on humans, the environment, and the economy. And of course, since we are studying these severe systems being tropical cyclones, we will be looking at strategies that we can use or put in place to mitigate or prevent or reduce the impact of these systems. So without wasting more time, let's look at our associated weather patterns. So what you have here on the diagram is a cross-section of a tropical cyclone. And we notice that the cross-section of the system is basically showing us the different parts of the system and of course the clouds that will form and the parts that will be without the cloud. So you see here up there, they said this is the anatomy of a tropical cyclone. So we are basically breaking down the structure or the makeup of the system. So that's what we are looking at over here. Now, of course, they're saying that we are looking at the vertical dimension of the system. So what does that mean? So we're looking at how it will look like if you were to cut it into half and look at the side view of the system, because that's what a cross section is. Remember that. So we see that in our cross sections we have the first vortex, which is the side, and we have the second vortex. Now we have spiraling rain bands in these two vortexes, and they are formed due to the ocean air rising up and forming clouds. Remember, we discussed that when we were looking at the mature stage. And we said due to this, we have cumulonimbus clouds forming in the first and second vortex. And we also discussed something further. We looked at what will happen in the eye. So in the eye, we will have air moving from the upper atmosphere. And we said the air in the upper atmosphere is cold and dry. So this cold and dry air, remember, it will always sink. So it will sink at the center of the system, and as it sinks, of course it will be moving from a region of high pressure to low pressure. So as it sinks, it will be warming up adiabatically. And since it is warming up adiabatically, you are going to have very hot or stable weather conditions over the eye. But we will not have any moisture, so there will be no precipitation as a result. So if you look at the top view of what we are looking at, so the eye over there will have no cloud cover, no winds, so it will have relatively stable weather conditions. And around the eye wall, you'll have your most intense cumulonimbus clouds that will lead to hurricane strength winds and hurricane strength storms forming as a result over there. So I hope we are fine with that. We understand what we have. Now, let us then just break the different fragments apart. So what conditions are associated with the eye? So the first thing is that in the eye, we have the highest pressure at the top. So here at the top, you'll have a high pressure, and at the bottom, you'll have a low pressure, right? And our air will be moving from high pressure to low pressure over there. So I hope we are fine. So that's what you will be having in the eye. And because of that, so our notes here are showing us that we will have descending cold air in the center of the storm. And remember, this descending air, since it does not have moisture, it will lead to stable conditions. And what does that mean? Stable conditions means there will be no cloud cover, there will be no wind, and the air pressure will be below 1000 hectopascals, which means we will not have rainfall and in that region. And remember, as this cold air is sinking, it is warming up adiabatically, so it is increasing in temperature with a decrease in latitude or in altitude. Sorry, with that decrease in altitude, we will be having an increase in temperature, and that is what we call adiabatic heating. And in essence, we are basically saying that there will be no precipitation at all in the eye. So those are the conditions of the eye. I hope you are fine. This is what you need to know for your exams. Know that we do not have any rainfall over there, and it's because of air moving from high pressure to low pressure, and as it sinks, remember this cold air is dry, so it will be warming up adiabatically, or there will be an increase in temperature with a decrease in altitude as a result. In the eye wall, we are going to experience slightly different conditions from that of the eye. I hope we understand that. So for starters, I just want us to look at a picture identifying the eye wall. So if you look at the diagram on the side, so this is showing us a fully developed tropical cyclone in the mature stage. And all of us can agree that where there is a hole-like structure, that is the eye of that particular tropical cyclone or hurricane. And what we are looking then at is the surroundings of that particular tropical cyclones, and that's what we will call the eye. So that's what we are really looking at when we look at the sides of the cyclone, right? And so if you look at the diagram then on the side, we are looking at if you look at the diagram on the side, you'll notice this is the eye, and you see that we have gently sinking air at the eye as air is moving from high pressure to low pressure. So this is the eye wall, and if you notice, then we have a specific types of clouds that will form at the eye wall, and you see we have the symbol CP there, and CP stands for cumulonimbus cloud. So we have rapidly rising air over there, which leads to rapid condensation and the formation of cumulonimbus clouds. I hope we are fine with that. And of course, in the upper atmosphere, we will have air conversions. So since we have air diversions in the upper atmosphere, and it means this air is cooling down as it rises over there, and it leads to the formation of cirrus clouds, and those are relatively cold clouds that are found in your highest latitudes. Um, I hope we are fine with that, and they are gonna lead to hail forming as a characteristic. And you see that on the outermost parts of the system, you have cirrus clouds. So you have cumulus clouds forming as a result on those sides. So let's just look at our notes here on the conditions of the eye wall. So the first thing we need to know, of course, is that the eye wall consists of a ring of tall cumulonimbus clouds. So that's what we need to know. That's the first thing. So it has a ring of tall cumulonimbus clouds. So those are cumulonimbus clouds. And the thunderstorms that produce heavy rainfall and usually strongest winds are found in the eye wall, right? And the changes in the structure of the eye and eye wall cause the changes in wind speed, which will indicate how intense the storm is going to be. So the structure of your eye wall will tell us how strong in intensity the system is going to be, how well formed the two vortexes are determined by the clouds or towering cumulonimbus clouds that will form around the eye. And again, we say that the eye wall is the strongest part of the storm. Remember that, with the strongest section being the first vortex where the dangerous quadrant will be formed, right? So the air located in the eye wall moves faster than any part of the storm, and it pulls in warm ocean water to fuel this system, and it leads to it intensifying over time. We are going to look at how that happens as the system moves over the ocean, when we look at how to track the movement of the system in the northern and southern hemisphere. So that's what will happen in your eye wall. So those are the conditions you should know and understand about that particular part of the storm. We then also need to think about what will happen in the dangerous semicircle, the dangerous semicircle or dangerous quadrant. As I said, this is the strongest region of the tropical cyclone, and it is always located in the first vortex of the system, right? And how does it form? It forms as a result of coinciding winds around the storm center, and that is basically where your easterly winds will be coinciding as they move towards the system or the tropical cyclone system. So that will make the strongest disturbance to be formed there in that quadrant, and as a result we'll have the highest winds, we'll have the highest storm surges from this region. We'll see that our ocean water will increase when this region affects, or rather as it moves over this ocean surface, and we'll have the highest rainfall, of course, as a result. So remember that, and remember that the dangerous semicircle or the dangerous quadrant should not be confused with the other strongest part of the tropical cyclone being the eye wall. So the eye wall and the dangerous quadrant are not the same thing. The dangerous semicircle forms because of easterly winds coinciding in that fragment of the system as air is rotating around the system. And the eye wall forms due to rapid evaporation and rapid condensation, which leads to cumulonimbus clouds forming. So let's not confuse the two parts, right? Let's make sure we do not confuse the two parts, please. Let's then look at the changes in air pressure and wind speed in a tropical cyclone. Now, for us to understand this part, I want us to think about the diagram that is below here. So that in this diagram, we are showed changes in air pressure and the changes in wind speed. Now, I want us to look at a relationship. Now, remember, this will be your first vortex. This will be your first vortex, and this will be your eye, and this is the second vortex. So if you look at the diagrams as well, the graph is showing the first vortex, the eye, and the second vortex. So let's think about it in that way. Now we notice that your y-axis is showing you how we get to have an increase, and of course it means now as you move up, there's an increase. As you go down, there's a decrease. And that's what we want to observe in the graph as well, looking at the relationship between changes in air pressure within the different parts of the system in respective to the changes in wind speed, of course. So if we look at it in the first vortex, we notice that the air pressure is relatively high. And you'll remember that this is a mid-latitude cyclone, and a cyclone is a low-pressure system. And we know that in a low-pressure system, pressure increases as you go away from the system. So it will only make sense that as you go away from the eye, the pressure will be increasing. Are we fine with that? I hope you understand that. So if you look at the graph, it's showing us exactly that the pressure is increasing as you go out of the system. But we know that the opposite is also true. So as you go into the system, the pressure is decreasing. So if you look at this graph, our air pressure is decreasing towards where the eye is, towards the center of the system. But now we notice that the opposite is happening with wind speed. So we get to have a very weaker winds outside the walls of the system. So we see that as you go closer to the eye wall, our pressure is intensifying, our wind speed rather are increasing as our pressure is intensifying here at the center the system. So that's the relationship the two will hold. And you'll notice that, of course, in the eye wall you'll have cumulonimbus clouds and that are associated with very extreme storms and devastating rainfall that is very destructive in nature, and we see that the wind speed will be relatively high in those parts of the system. Hence the graph is showing us that. So I hope you understand that. You will be expected to analyze this in different graphical form. That was just one of the graphs you need to be able to analyze. So now let's look at this other graph. So this graph is showing us again pressure, changes in wind speed, changes in temperature, and the rainfall as well. So please be able to look at your keys in the y-axis. You see that our pressure is measured in millibars, our temperature is in degrees Celsius or centigrade, our rainfall is in millimeters, and below we are being shown the directional movement of the system, and also the amount of hours where in which the changes happen, and the wind speed is in kilometers per hour, of course. So now let's start looking at the pressure, because remember the system is largely influenced by changes in pressure. So we notice that our pressure is above 1000 hectopascals at first at 0 hours. You see it's above 1000 hectopascals, and we see that now over time the pressure is slowly decreasing. It's slowly decreasing, and as this pressure is slowly decreasing, we also notice a change in temperature over here. So we see that our temperature was roughly 27 degrees Celsius, and it spiked up to roughly 30 degrees Celsius, and it decreased to 25 and downwards. And you see that over here you'll have your eye walls, remember from the previous diagram. So you'll have your eye walls, and why am I saying so? It's because we relatively have lower temperature in this region, because remember, in the eye walls we'll have rainfall, and you know that when we have rainfall and thunder, the temperatures are relatively low in those times. But we notice that the wind speeds start out as very calm, and then they spike up from 25 kilometers per hour to up to 225 kilometers per hour in the first vortex of the system, you see. In the eye wall, to be specific. So you see that we experience those changes, and of course in the eye wall again, you see that in terms of rainfall, you'll have the highest rainfall over there in the eye wall, and the eye wall of the second vortex as well. Now something different of course is happening at the center. We are being shown here that we have subsiding air, and we see that we have the lowest pressure at the center. And if you look at the wind speed, the wind is relatively low, so there is no wind. You see it extends to roughly 0 to 20 kilometers per hour. And those are conditions of the eye. Remember, we say we have stable conditions, so there is no wind, no cloud cover, and you see that the temperature is relatively high as well there because of adiabatic heating, as this air is subsiding at the center of the system. And if you look at your rainfall, we see that there is no rainfall. Again, there is a sharp decrease in the rainfall at the center of the system. So those are the conditions of the a tropical cyclone. You need to be able to identify them either when represented in a diagram, in a graph, such a graph of course, so that you are able to respond to examination based questions on this. We also of course have to consider the cross section then. Cross section, very important. Remember, the cross section is supposed to teach us about the system itself. What do I mean by that? So the cross section shows us how the system will actually look like when all the fragments that make it are sort of cut into and looked into in a more depth sense. So if you look at the system here, so remember the part in blue is our dangerous quadrant, right? But we are not there, and we see the arrows of course also show us the circulation, so it means this is in the southern hemisphere. But again, as I said, we are not there, right? We are looking at cross section. So when you are asked to draw the cross section, please remember that this is what you draw. So you draw what you see above, not the circular part that you saw at the bottom. So you remember, in your cross section you'll have basically, for you to master it, think about how the system will form, right? We know that, and we've taught you that you'll first have air converging towards the center, because remember, this is a cyclone, and we know that when this air converges, it also rises. So this air will rise, and as it rises, remember, it has latent heat, so this latent heat will fuel up the system, but again, as it rises, it cools down. So it means when it gets to the upper atmosphere, air diversions or upper air diversions will happen, right? So that's what will happen. And remember, condensation, rapid condensation will happen. Now, as a result, what do we have? We end up having cumulonimbus clouds forming around the system. So we end up having these cumulonimbus clouds around the system. And we also taught you that now something interesting happens at the center of the system. So we start having air sinking down, and we remember we said this is cold dry air sinking, and as it sinks, it warms up adiabatically, which simply means there's an increase in temperature with a decrease in altitude. Remember we said that. So this will be a cross section, and remember, in your cross section you must label that you have cumulonimbus clouds, sections of cirrus clouds in the upper atmosphere, cumulonimbus clouds along the eye wall, stratus clouds in the outer parts of the vortexes, then label the eye and also the general movement. So it will be moving from the east to the west. So also label that it will be moving from the east to the west. So that's what you'll have in your system. Remember, that's how you draw your cross section. So I hope we are fine with that. I want us to then look at the pathway of the tropical cyclone. Now, what do we mean by the pathway? The pathway basically looks at how does the system affect the northern and southern hemisphere. So we are basically thinking about the major tropical cyclone zones, in terms of how it will form and how it will affect those regions. So you see that the peach part is showing us the major tropical cyclone zones, and you see that hurricanes will form between August and October, in June and October, in parts of North America, and we see that in parts of Asia, your typhoons, remember they are called as such there, will form between June and December, and in the southern hemisphere, they will form between January to March. Your tropical cyclones will form there. So if you look at this, your arrows are showing you the pathways in which they will travel. So they will form in those particular regions, right? Now, I want us to then think about the pathway in the northern hemisphere. So remember, it will form where? It will form at 0 degrees. I mean, that will be the expectation. It will form at 0 degrees. What's this? Will form outside 0 degrees. Sorry about that. So it means it will form somewhere here, 5 degrees outside the equator. And it will move from east to west, of course. So it will affect the east coast of Asia as a result, right? Because it forms between 5 degrees and 30 degrees. But now looking at an actual movement of it in the northern hemisphere. So it will follow this route. So down here, you'll have your 0 degrees. So you'll have your 0 degrees, and then you'll have your 5 degrees to 30 degrees. So it will start here and it will move in a northwesterly direction. So it moves in a northwesterly direction. Because where is it coming from? It is coming from the east. So it will move in that direction. So if you look at the arrows, we also being showed the changes over time. So if you look at this part, it says current storm position with a maximum of 34 and knots, wind radius drawn as a dash circle. So that's what you see over here in the first part, right? And you see there's a notice that says danger area to avoid. So people should avoid being in the pathway of the system. Okay, and then to continue, we see that we have this system being widening up within the 24 hours, and we see that winds are still 34 knots in radius, and this is a 24-hour forecast of the position of the system, right? And again, we see that it is advancing with time. So if you look at in 48 hours, we see we have 20 nm radius added to 48 hours. Now we're looking at a 2-day space, and winds are still 34 knots in that particular region. So you still have the shaded area showing that that's the pathway of the system, and these are regions that should be avoided. And looking at it at 48 hours, that's the position again of the system. If you look at 300, what's this? We have a 300 radii, and that's 72 hours. And we see that again we have now the largest radii. If you look at it, it's quite expanded even more, and it means the system will affect a greater region. And remember, if you're asked what may cause its expansion, remember rapid evaporation and condensation over time allows for the system to expand as it moves to the westerly part of the country. So as it moves like this, as it moves that way, it is also affecting the parts it passes over. So in 72 hours, that's the position. And you have strong winds again, and the system is at full-on hurricane strength, and it will affect certain regions, of course. So please take note of that. So if it's in the northern hemisphere, your diagram will be showing a system that is moving in a northwesterly direction, while in the southern hemisphere it will be the opposite. So I would like for us to look at that. In the southern hemisphere, you are going to have slightly different a slightly different movement, of course, and remember that the movement is influenced by different actions, different systems, and of course different environmental conditions. So for starters, this is a website called Zoom Earth. So this website is used to trace the development of tropical cyclones. So you must note that you guys can visit the website. Just go to Google and search Zoom Earth. So I am using the website just to help you guys sort of get what is happening when we have an actual live tropical cyclone occurring. Yeah, so if you look at the part below, it is showing us the date and the time of the day in which the system develops. Of course, this is just some information about the website that we are using, called Zoom Earth. You see, now it is showing you that this tracks tropical cyclones, and gives us forecast maps, with the data from other different sites. So the video does not intend to break any copyright rules or infringe any copyright rules, but it is being used for educational purposes for high school learners to understand how a tropical cyclone will develop over time and what parts, of course, will it affect as a result. So if you look at this now, it is showing us where the system will start. It will start up there and it is going to move to that direction. So it is starting in the eastern side, it moves towards the western side. So let's see that. Now I'm going to add some days. So as I'm adding the days, you see that the system is this is showing us where the system is, how far it has developed, and so on and so forth. And we see that these clouds are so dense around this particular place, so it's showing us that the system is traveling over there. So please just follow the dot over there. It is showing us where the system is at a specific point. So on the 24th, it was here, and let's just check. The wind speed was 90 kilometers per hour and the pressure was relatively 994 millibars or hectopascals, right? So that's what you will relatively have or generally have in that particular system. So we also add the we also look at what will happen when you continuously add the date. So now it's the 25th, it's in the morning, so the system is somewhere here, and you see that the pressure is low as they are showing here. So you have your lowest pressure and the winds are relatively 55 kilometers per hour. Now we see that the system is far inland, so it is showing us that it is getting destroyed at that section of the system. Now if we were to click here and just go back a bit, so we are gonna have 994 millibars over there, or hectopascals. So it is showing us that that's relatively where we have the lowest pressure of all if you trace over here, and it is showing us that that is where the cyclone was most mature, right? And you see that at that particular point we have the highest or the strongest winds, which are at an intensity of 95 kilometers per hour. So the winds are very strong, and it is showing us that it's in the mature stage. And of course, since we taught you the associated weather pattern, you expect that over there you'll have the eye being fully developed, the strongest winds, and the heaviest storms and rainfalls and the most devastating conditions as a result. So that's what you'll expect at that particular region, right? So let's remember that. Apologies for the noise over there. Yes, so you are gonna have the most severe. And remember now, these tropical cyclones, remember we said they have names. So you see that the winds are very strong at this point, and the cyclone name is Dom Ana, or tropical cyclone Ana. And you see they are saying that down there it is a moderate tropical storm, so it is not as severe as the other ones. Okay, and then let's just look at on the 25th, it was far inland, and we see that the wind speeds decreased. Why? Because we're now starting having friction, having less moisture, so this and has having less heat, and so this system is exposed to less heat and moisture. Rather, it is exposed to terrestrial radiation, and more friction from mountains and vegetation, and as a result the pressure starts increasing in the system. So we see that on the on we see that that was the last point rather that the system reached in. So we see that here the wind speeds are 55 kilometers per hour, so they are very very weak. But you notice that of course we are going to have some associated weather patterns, such as terrestrial flooding or inland flooding, coastal flooding in those particular regions, um, um, coastal flooding in those particular regions, and the system of course will get destroyed after that. But something interesting is happening as the system is developing. So if we move the map to the other side, we see that there is another tropical cyclone developing. So you see that the date now is, let me just alter the date. So the date down here is the 26th of January. So if you go to the other side, you see that we have another system forming, right? So it's occurring soon after Ana. And since they are named alphabetically, the name of this system will start with a B, right? So this is Tropical Storm Batsirai or Batsirai. Batsirai, yes. So that's the name of the system. And we see that it developed over there. It's also moving in a westerly direction, or it's moving from the east to the west, right? So this is showing us the pathway in which this system will travel. So if we increase our dates over here and put in the 28, so we see that on the 28, the system, yes, so we see that on the 28, the system has a wind speed of 95 kilometers per hour. And remember, that was the high speed of Tropical Cyclone Ana. But we see that again as time moves on, or as the days pass, on the 29, the system has 120 kilometers per hour of wind speed, and you see that the pressure is 992. So that is showing us something, that this system relatively has a stronger intensity than the strongest intensity than Tropical Cyclone Ana. And of course it continuously moves, and something beautiful about this is that there is some predictions of what will happen in days to come. So you see the days that are in gray, it's just a prediction by meteorologists of what's going to happen in the coming days. So from the 30th to the 3rd, you see that they forecast that the storm will reach intense an intense state. So it means it's going to be a category 1 tropical storm or tropical cyclone, with winds that are 195 kilometers per hour. And again, we can notice now that Madagascar is going to be a victim again. It's going to be affected by this intense system. And if we move along, since it moves to the southwest, so it's going to that direction. So we may expect that parts of Maputo or parts of Mozambique will be affected, and parts of South Africa as well, it may be affected as a result. So that's what we have over there. So this is the forecasted storm. So first we looked at Ana. So Ana got destroyed, and you see on the 29 it's no longer on the trade, but on the 29 we have another storm which is traveling around here, which is has the wind speed of 120 kilometers per hour, which is very very high when compared to the highest wind speed of Tropical Cyclone Ana, as Tropical Cyclone Ana had the highest wind speed being 95 kilometers per hour. Okay, so now this is just me showing how it will move. In exams, you are going to be asked about these systems. Please make sure you are able to interpret this. Look at your wind speed, look at the changes in the pressure in relation to the dates as well, looking at how long the system will last. So that's what you should know and understand with regards to this. Just for reinforcement reasons, I want us to then look at the pathway in the southern hemisphere using a map, because remember, you will not be given a live footage like I did as I was explaining in the examination. So you also need to be able to work with diagrams. To start with, we need to understand that the system will form here 5 degrees outside the equator, right? And remember, in the northern hemisphere it was going towards that direction, and we said it's going in a northwesterly direction. So in the southern hemisphere it will be opposite, it would be taking the southwesterly direction. So you need to take note of that over there. So the diagram for the southern hemisphere will be showing the system moving towards the southwesterly direction. Now, a typical example is what happened with tropical cyclone I Die. So when we had tropical cyclone I Die in few years ago, we had the system affecting parts of Madagascar before it got to parts of Beria over there. So we need to always remember the movement. So because of that now, it means in a way parts of Africa will always be shielded a bit from a devastating system. But there are times where it happens that as soon as the system has affected Madagascar, it fuels up again. Because remember, Madagascar is just an island there, so the system will come from that side and go over Madagascar. So remember, as it moves over the land, it's gonna be losing the heat source, the moisture source, and it's gonna weaken as a result. So but something we need to take note of is that it gets to the ocean in the end, and it gets a chance to fuel up. So sometimes it doesn't get enough time to fuel up, and it may become a weaker tropical storm as a result. So now, looking at tropical cyclone I Die, so we see that it was located 19.3 degrees south, because remember now, where did it start? It started 5 degrees where south. So it is now located 19 degrees south, which will be roughly here 19.3 degrees south. And again, it is, when you look at the part of the eastern hemisphere it is at, so they are saying it is at 39.2 degrees east. So that's the statistic. So it was found relatively in that position. So that's what you'll have. Now, we're also interested in this intensity of the winds. So the winds are 175 kilometers per hour. So it's really strong winds, and it is moving in a westerly direction, of course, at 13 kilometers per hour. So we need to take note of that, and because of this, it shows us that it has fueled up and will affect parts of the west coast in Beria. But again, now the most interesting question is, what changes should they expect in Berea as the system is approaching? So that's exactly what we need to look at, the associated or resultant weather conditions. So the first thing I want us to talk about is storm surges. So storm surges, what are they? Your examiners like asking you guys about storm surges. So the first thing is that you need to be able to define what a storm surge is. Now, a storm surge is known as a storm flood as well, or a tidal surge, or a storm tide. So those are other alternative terms they may use in the exam, but just focus on storm surges. That's the concept we mostly use in your papers. Now, what is a storm surge? So a storm surge is a coastal flood or a tsunami-like phenomenon. And what is the effect of this phenomenon? It leads to rising water, commonly associated with low pressure systems, such as what? Tropical cyclones. So that's a storm surge. So it's basically rainfall that is going to lead to coastal flooding. I hope we are fine. So if you look at the animation here on the screen, it's showing us exactly what will happen when we have a storm surge. It's an animation of that. So normally our water, you see in 2020, the mean sea level was in that position. But we see that when we have a storm surge, water increases in a speedily format, and it goes up in altitude, it goes above sea level, and it ends up flooding coastal regions. Now that's exactly what a storm surge is and what it does. And remember, they happen because of a so a tropical cyclone raining over the ocean. So as it comes, it increases the water that you'll find in the ocean, therefore leading to coastal flooding. And how is it measured? Remember, we say it is measured as a rise in water level above normal sea tidal level. So we have a surge in the normal water quantity within the ocean, and it forms as a result of coinciding winds around the storm center, being easterly winds moving the tropical system. So we can also take it to the dangerous quadrant aspect of things to say it has an influence in this. So when these winds submerge in this dangerous quadrant, they lead to water rising above normal sea level, leading to the formation of storm surges. So in real life, you'll have these storms affecting regions in that format. So they may lead to houses flooding, as you can see in the animation, lead to trees being uprooted, they damage water systems, they destroy everything, and may lead to loss of life as a result. So that's one weather a condition that results from tropical cyclones. Let us look at more. We also have what we call inland flooding. What is inland flooding? Inland flooding, for starters, is also known as urban flooding because it usually happens there, and it's also known as flash flooding. Now, what causes it? It is caused by intense rainfall from tropical storms. It may also be caused by short-term rainfall from line thunderstorms, and may be caused by moderate rainfall over a long period of time, over several days, which may overwhelm the drainage infrastructure. So that's what inland flooding is. Now, when we have a tropical storm moving far inland, we may have inland flooding as a result due to these storms or cyclonic clouds bringing rainfall to the interior. So if you look at the animation here, it is showing us how inland flooding will happen, and it's usually common in areas that have water. So if you look at this, water is increasing slowly far inland, and that's what inland flooding basically is. So it's water just increasing due to us having short-term heavy rainfall or moderate rainfall over a long period of time. So the animation here on the side again is showing us the devastating effect of this rainfall, especially when it happens along a river or the ocean as well. So it may cause damage to infrastructure and affect regions as a result. Okay, so that's what we have over there. And then coastal flooding. So let's just look at coastal flooding. So remember, coastal flooding may be as a result of storm surges. So the animation that we looked at in the previous picture was showing us exactly that. It's here now. By definition, coastal flooding is when the coast is flooded by the sea, right? And what causes that? It is caused by a surge in a severe storm, such as that is the one that is brought by tropical cyclones in the east coast of continents. So what will happen is that water slowly increases, as you can see here, and may flood the coastal regions. So guys, the resultant weather patterns are not complicated, not hectic, and of course we may ask you to give us the resultant will give us, of course, um, so in your examinations you may be expected to give us the resultant impacts. That's what I meant. So you will be expected to tell us what impact does this have then on the environment, on humans and the economy, which is something that I want us to look at right now. So on the impact, so we're starting with the impact on humans. So the positive, something you must note, a positive impact on tropical storms is very minimal. Please take note of that, right? The positive impact is very minimal. So that's why we don't usually talk about it. So what we usually make reference to is that this system will remember they occur late autumn. So as a positive impact we will just say that these storms will bring rainfall in the late parts of summer in the east coast of the country, and may enable agriculture to take place in the long term. Now, I know this is a crazy example to put in, but now let's think about tropical cyclone Eloise last year, for example. So it affected parts of Mozambique, of course, but it disintegrated, right? As it got into the land, and it was just a storm. So these storms brought rainfall to Limpopo, parts of Limpopo, and last year Limpopo was facing severe droughts at the time. So the storms that were brought by Limpopo, by this cyclone on the Limpopo region, were very beneficial for it in terms of agriculture in the long term. And again, we can think about what happened to the Val Dam. So the Val Dam as well filled up, so we had more water for the winter season. So those are just some of the impacts. So the rain replenished the rainwater will replenish our dams and rivers for domestic use. So we did not have a droughty winter last year as a result of this. Now the negative, of course, is too much. It's too much. So the negative is too much. Now if you think about it, The first one is that these cyclones will cause terrestrial rainfall. And of course, when we have terrestrial rainfall, we are going to have inland flooding. So there's a high risk of inland flooding. And remember, they are associated with strong winds. So these winds will damage infrastructure, basically. The power lines, it will shatter windows, it will rip off roofs. The storm surges may cause flooding to coastal regions and damage of infrastructure over there. Roads and bridges will be washed away. People will lose their homes. In the long term, agriculture will be affected as plants will be uprooted and may cause starvation. Because remember, food access will be affected, and food insecurity will be affected as well. Now, it damages water systems and sewage pipes, so the water quantity and quality is eradicated, right, or affected negatively. The wind will damage water power lines. It also leads to loss of life, so the death rate will increase. So it leads to deaths and injuries because of these winds and floods and storm surges. And we may have disease outbreaks, especially waterborne diseases such as cholera. And we may have a major financial strain on families as they have to fix houses and fix businesses that may have been lost. Again, we know that subsistence farmers will lose everything, so they may starve as a result. So these are all the negative impacts on humans. Let's look at the environment. In the environment, we said we are going to have more rainfall for rivers and beneficial for aquatic life. But now to build up, we remember I said we have more negative than positive, really. So the strong winds will lead to rapid rise in sea level, and that may not be so good for aquatic life. The swells of waves again are dangerous for fishermen, so people may die. Remember, people are part of nature, the ecosystem. Floods and salt water destroys agricultural crops. We know that as well. That's an impact on the environment. Flooding will lead to a rise in river levels, and we may have mudslides and landslides, which may lead to deaths of animals and loss of biodiversity. So our ecosystems and biodiversity will basically be destroyed or affected. The livestock will drown because of this flooding water. There will be a lack of clean water, and it also threatens food security. On the economy, so remember, a positive is that when we have weaker storms, the result is that at the center of the continent late summer, these systems may aid to fill dams and rivers, which will enable for agriculture in those regions. So that's a positive. And you see that the positive has been recurrent, really, because it may be applied to the economy, to humans, and the environment. Now, on the economy, remember, we know that airports will be closed because planes can't fly because of the devastating conditions. Harbor facilities, which are facilities, business facilities that are found in the coastal regions, will be affected and closed, and damaged, of course, to be specific about the effect. No trading is going to be possible. It will be costly to repair the damages. People will lose jobs, and unemployment will increase. As a result, there are going to be high medical expenses, and again, it is gonna put a strain on local civic services. So those are all the impacts on the economy. associated with the system. But now we also have to propose solutions, right? We can't focus on problems. So this is a picture from Glenn Samai from the Department of Education in Western Cape, a geography educator like myself. So he uses this diagram most of the time, and I believe it is a very, very nice summary for the learners in looking at precautionary strategies. So we are looking at that. So remember, with precautionary strategies or management strategies, so we look at how do we reduce the impact, because we can't take away the impact entirely. So we'll have to be realistic about the solutions we propose. So the first one is that we need to monitor the development of tropical cyclones. So the Zoom Earth website, for example, that I showed you is one of the monitoring platforms that meteorologists will use in monitoring the development of these systems. Satellite tracking is used to it can be developed and used to monitor the path. So your satellite images will be very helpful at that. Air radars are connected to that as well. So they assist or work as remote sensing to measure the pressure of the system in the eye, which assists us in tracking it. So we also need advanced weather predictions and warnings. So that's what I said. So air radars can be used for that. Now satellite-borne sensors to collect details. So to look at rainfall rates, for example. So your air radar and remote sensing zones will assist with that. Again, a land radar is important. It assists in tracking changes in your sea level, and then there's developing storm as well. Early warning and communication systems for people to prepare. So after getting these systems in place, a good communication is necessary to warn citizens. And again, it assists in initiating the evacuation process in lower lying routes, right? So for people to be safe when the storm comes. We also need to ensure that infrastructure is in good quality. So stronger buildings need to be built and put in place, especially in flood-prone areas. So they need to have good building quality so that they survive the storms if they occur frequently over there. So again, with livestock, it needs to be kept in barns to protect them against the wind and rainfall, right? People should stay indoors. It's not safe outside, so people should stay indoors to protect themselves against the flying debris, winds, and rainfall. As the system approaches, there needs to be an upgrade of technology in less economically developed countries. So remember, these countries have a low development rate, which means their infrastructure may not be of quality to withstand the storms. They may not have good communication systems. They may not have good early good evacuation programs for people. So a lot of lives may be lost as a result. So technology needs to be improved again now, in also ensuring that the medical treatment provided there is inclusive of the emergency situations that will arise. So good medical care is important to reduce outbreak of diseases and people dying. So good emergency services that are well equipped are important to survive the storm. Again, local civic services should be well prepared to assist. So the local government should have put arrangements in place to save people's lives. So that is all we have for now. So in summary, we have looked at in our session the associated weather patterns with the eye wall, the dangerous quadrant or dangerous semicircle, and we also looked at the resultant weather conditions. So we looked at storm surges, which are storms that result from air submerging in the dangerous quadrant. We talked about inland flooding. When the system goes far inland, it may lead to inland flooding. We also talked about coastal flooding, which results from an increase in altitude of the water in the ocean, which may lead to the flooding of coastal regions. We also looked at the impact on humans, the environment, and the economy. So this is a very important section. Remember, guys, as you are going to be expected to answer examination based questions and making reference to this. We then looked at mitigation and management strategies, because remember I said here we are proposing strategies to reduce the impact. So the strategies do not take away the impact. The impact is still as dire. So we need to take note of that important point with regards to these systems. So I hope we understand the work we looked at today. In the upcoming sessions, we are going to have tropical cyclones lesson number 3, which will be an application of all the work we've covered so far. I hope we understand all of the work that we've covered. This marks the end of content lessons for tropical cyclones. We shall be looking at application videos, an application video in the next climatology sessions of our online classroom. I hope you're still enjoying my classes and are fully benefiting from the content. I always try to take it as slow as possible, so that you guys fully grasp the concepts and the content that you need to know for each and every topic in your geography examination guideline. Thank you for tuning in today. Remember to like the video and subscribe. Also share with other grade 12s and help us grow the Pedagogical Science Institute family. This is a program specifically known as the School Student Support Program, designed to help you guys get the best results possible and understand the content in the most deepest sense possible. Thank you for tuning in. I am Mr. P. Mbuyisa, your instructor for geography. Cheers. Enjoy the rest of your day. Bye.
Audio Jungle.